Hey guys, it's Chris from the Controller Talk podcast. Danfoss will be hosting a virtual series around sustainable cooling called Rethink Live starting in June. See the description for more info, and with that, let's get the episode started.
Hello and welcome to the Controller Talk podcast presented by Danfoss North America. Our goal is to bring you information about using Danfoss controls in the supermarket and warehouse industry, specifically in the U.S. and Canada. We're doing these twice a month for now. You can catch these podcasts on Spotify, Google Podcast, Apple Podcast, or as the saying goes, wherever you get your podcasts. Subscribe so you don't miss upcoming and released episodes. For the video version, if you so choose, check us out on the Danfoss North American YouTube page. Search for Controller Talk to see the video library. I'm Dave Yoder, along with Chris Brown. Hey Chris, it's occurred to me that we're working for a Danish company, yet all of the North American tech support we provide for drives, heating, mechanical, and of course food retail or supermarket electronics is based here in the USA.
Yep.
When you call someone for supermarket electronics support, you're going to get someone in either Maryland or Pennsylvania.
Plenty of people on the side of the pond, and I don't know,
Right.
it's just larger scale. It's kind of the world we live in, right? I mean,
Right.
Everything's so global that I don't think it's completely unsurprising to hear that.
Right. But then again, for support, you're going to get someone in the U.S.
Yeah.
And after hours, you might get someone outside of Maryland or Pennsylvania, but nonetheless, they're still here in the U.S. where they understand more about our applications.
That's right. Yep.
All right. So, Chris, we're going to jump into stepper valves this time around. And we have, obviously, modules and we have valves. And we're going to take a little step back in time here and kind of get back up to where we are and explain a few things. But back in the dark ages, Danfoss had this AKC 164 case controller that had an option for a valve on the suction side of the coil called a KVQ valve. And this valve was kind of crude, but it was also an effective stepper valve of sorts. And this case controller, there's still some out there. Not a lot, but there's still some out there.
Get the calls every once in a while.
That's true. Yep. So this KVQ had 4 wires to it. This one had 2 for a 24-volt AC heater to heat up an oil inside the actuator, and it had 2 for a sensor inside the actuator that read that oil temperature. When it was time to start closing the valve, the case controller sent power to the heater. The sensor helped keep track of the plunger position by recording the oil temp and acted as a safety for overheating as well. These were reliable, tough valves. We had a customer in Wisconsin, I remember, sent one back a few years ago. It looked like it had been used and abused, to say the least, but a defrost heater fell on it and almost melted through it, but it was still working. And they sent it back to us and said, hey, I just want you to know this thing's still working, but we're going to replace it anyway.
Put it in the museum.
That's right. Yeah, it was pretty cool. So this KVQ valve was unique, but it was kind of a stepping stone to the modern 4-wire stepper valve.
Yeah, that's kind of where we are today. Is the KVS is our bread and butter model for stepper solutions on the suction side of the system. So right now, today, with what we have, it's 2 sizes. It's a KVS 15 or 42 that you're looking at when you would make a selection here. It's not to the level of granularity of the AKVs that we talked about on the last podcast, where you have 6, 7, 8 different sizes to choose from for capacity. Here, it's a much larger range that these stepper valves cover with one model. So the sizes, anywhere from 5/8 to 1 5/8, you're going to see different options for each capacity of valve as far as the 1542. I know a lot of guys would probably just jump right to the connection size to make a selection, or if they're replacing a valve from some other vendor or supplier. But my middle name's Cool Selector, I guess, at this point, right? So I would always recommend that if you don't know exactly which valve you need, that Cool Selector and checking the capacity. I mean, you've got all those different factors with refrigerants and the capacity and the design temperatures that are in play. So we need to make sure that we are taking that all into account when we select the valves. So yeah, no harm in checking these with Cool Selector to make sure you're choosing the right one between the 15 or 42.
All right, we've talked about Cool Selector in the past with the AKV valves, and the same thing applies to the KVS valve if you need to size those up.
Yep, I get kickbacks every time somebody downloads one, so.
Okay, well, keep them coming.
There you go.
All right.
Now, so I mean, as far as using the valves, I mean, the other parts of a supermarket case you're looking at here, right? You've got the defrost side. So, I mean, the valves are going to be pretty flexible there. So whether we're looking at a system that uses electric, hot gas, some type of maybe a reverse air, which is infrequent compared to the other two, or even time off defrost, the valve's going to be able to play nice there most of the time. I think hot gas is probably the one that has the most unique situation that you got to look at. So the controller that's being used with the valve, there's usually going to be a parameter in there where you have to pick and choose whether the valve needs to be closed or open during the defrost cycle for hot gas.
Yep.
So we would give you those options there so that the valve's in the right position. And then the other thing to keep in mind with the hot gas defrost is the valve does have a max temperature rating on it. So the valve, anything over 150 degrees Fahrenheit is going to exceed what that valve was designed to handle. So you just want to make sure that you're not exceeding that if it is a hot gas defrost system.
So by the time that hot gas gets to the case, is that 150 degrees usually a concern?
I'd say more than half the time it's not. There are some designs that we see come across, and maybe there are a little more unique designs, whether it's something with CO2 or something out of the box from a standard HFC system that, it's you could exceed it, but more often not than so.
Okay.
So outside of just standard supermarket applications, you could see this on some other things, maybe mobile refrigeration. So they're larger capacity valves a lot of times than maybe what a AKV 10 series would be. So they can cover a whole circuit as opposed to where an AKV you're going to have one valve for each evaporator. This could cover an entire circuit. So it's just something that puts you in the mind frame of how these are being applied to. They need oil. So in a lot of our stepper valves, not that we're seeing a ton of oilless systems. We have our turbo core compressors that aren't in the supermarket industry today, but oil is small amounts of oil to lubricate the motor is something too. So again, I don't know if you guys would necessarily run into that, but something to keep in mind is the refrigerant oil that we're using for the compressors. Some of that obviously bleeds out to the system. The valves are looking for some of that oil to lubricate themselves. As far as the control side, on the inlet side of the evaporator, you're going to have a TXV. So all you really need to control the stepper valve is a temperature sensor, whether it's in the discharge or return airstream of the case, whatever, wherever that's set up to control it. That's all we really need is the temp sensor. We typically don't see mixing and or combining, is probably a better word, of electronic expansion valves and these KVS electronic EPRs. The controls can fight themselves a little bit if they're not set up the right way.
Yep.
So most of the time if somebody's doing this, they have a mechanical TXV on the inlet side and then this electronic valve on the suction side. So as far as maybe manually operating these stepper valves, if we need to do some type of troubleshooting or testing on them, or maybe even leave them in a permanent position while we're waiting for a new board to show up, I guess could be a scenario here too. But we have a handheld device on the market called an AST-G. It's a valve driver for the KVSs and our other stepper valves too. Runs on a pair of 9-volt batteries. And again, you take the 4 wires off of the valve, land them right on this handheld device, and it allows you through a toggle switch to open and close the valve in different directions. We're not the only ones with a solution like that on the market. Sporlan has a SMA handheld, it's called. Really nothing too special about how they work, right? So you could take a Sporlan handheld and use it with our valve and vice versa, just a matter of wiring up the right way. Normally, I think it's a matter of swapping the red and green wires out of the valve to do that.
Right.
So, and mentioned earlier, we have the two sizes, the 15 and the 42 today. In the past, we had a little more granularity to other options. So there was a 22, a 28, a 35, and a 54 at one point. And yeah, there was, I'd say, probably too much overlap in how many different options we chose or had available out there. So they really went through and kind of narrowed it down to just keep it simple and go with the two options that covered 95+% of the applications that we were selling into.
Yep.
So you might come across some of those old valves, and if you have to replace them with today's options, yeah, it's you'll get a feel for whether the 15 is a better replacement for a 22 or 28, and maybe the 42 is a better for the 35 and 54. Worst case scenario, I'll put my cool selector plug in there one more time,
Sure.
at the risk of getting redundant here. And worst case, just run it through the system there and see which size you need to go with as a replacement.
Okay.
Older valves, the connection at the top as far as the wiring back into the stepper module that we would use with this. The older valves, it was a 4-wire cable that came right out of the head of the valve itself. So it was kind of housed in there. A couple years back, we changed that up a bit to where it's now a connection that's at the top of the valve, and you can kind of pick what cable you want to go with. So it's going to be an M12 cable, we know. But we have different lengths we offer. We have a straight connector at the top for this cord, or we do have some options for a 90-degree bend for that connector. If you're in a tight space, maybe I need to come out in that direction. So a lot of options we give you now. So you can kind of pick and choose length and connection type when it comes down to what you're using for the cord out of the valve. The valves are pretty interchangeable with these cables. So on the Danfoss side, the cables are keyed, so you can only plug them in one way. So there's no risk of kind of messing that up, so that you're not sending the pulses to the right side of the right motor or right side of the motor that we need to. Not completely sure about the Sporlan cables, but don't believe they're keyed. So you could potentially plug them in the wrong way if you're not paying attention to the orientation there.
Right. Yep. That's what I've run into.
Yeah.
All right. So let's look at some details. There's going to be quite a few details to run through, but so buckle up here, Chris.
Okay. I'm ready. Let's do it.
Okay. So we have some controllers that are built just to control one valve, and those are mainly for industrial applications.
Yep.
And most of the time we use an extension module called a stepper module. If you're watching on YouTube, I am showing one right now. But this module has the 4 outputs on it. So you can drive 4 valves with this module. So because you're programming valve settings into the controller, these modules can handle Danfoss, Sporlan, or Alco 4-wire stepper valves. The top of the module has a separate plug for valve power, and if you're controlling a Danfoss or an Alco valve, the power coming into that plug can be 24 volts AC or DC. If you're controlling Sporlan valves, the power to the plug can be 12 volts AC or 24 volts DC. But if you're using the typical Danfoss 24-volt DC 60 VA power supply, you can power a total of 4 modules or 16 valves on one power supply.
Yep.
So it's best to keep your stepper modules and your sensor modules on separate communication modules on the Danfoss system, or you could see temperatures fluctuating as the steppers move to new positions. So that's just something to keep in mind.
Yep.
If you have some kind of problem like that.
And just keep in mind with the power connection at the top of that stepper module that we also have to power the comm module up that's connected to those stepper modules as well. So if somebody's trying to use the same power supply there, just you want to make sure you're not going over that 60 VA limit, depending on how you're using that power supply.
It's recommended to keep them separate.
Right.
Yeah. Okay, now before we get any further, Danfoss has 2 types of stepper modules, and we want to talk about those just for a minute. So the typical 4-output module has a plug at the top for valve power, and that's it.
Yep.
Now, there is another module that's out there that you don't see a lot of, but it has the 4 outputs. It has the power plug at the top, and it has terminals for up to 8 sensors or dry contact digital inputs. But please do not try to install this module on anything but a pack controller or a case controller, because if you try to put it on the front end controller like a 255, 800, 800A, then it's not going to communicate. And then you're going to have to backtrack and get the right modules in.
Right.
So someday the front ends might be ready for that module, but right now they're not. But if you try to make it work, you're going to be in for a big disappointment.
Yeah.
Kind of like the guy that lost his password to a couple $1 million worth of cryptocurrency.
Lots of tears and Kleenex.
That's right. There's no crying in refrigeration and baseball, from what I hear. So if the valve's going to be installed more than 32 feet from the stepper module, you'll need to install something we call a valve filter. On the YouTube video, I have one here, and these are installed near the stepper module. So the key is if the valve is more than 32 feet from the stepper module, you put one of these in, and then you can run your wiring as long as 328 feet from the module. So inside this filter, there's 4 little inductors in here, one for each wire, and it keeps the current and the voltage constant across that distance, and it prevents things like a loss of steps. It might seem like it's just another part we're trying to sell with some kind of magic dust inside, but if you don't install it, you'll find out that you actually do need it. And typically, if your valves are installed at the rack, you won't even see these because you won't need them.
Yeah. I think some other people that offer stepper valves out there on the market, sometimes the solution's using a bigger cable to, especially on those longer runs, to account for it. But this is our solution alternative to that scenario of use your standard wire size, but drop this filter in if it's a long run.
Yep. Okay. So when you've got your hardware all set up and ready to go, and you're ready, then you'll program the board points into the controller, and the same screen will ask for the usual valve details, like your maximum steps for the valve, your step rate in steps per second, something called step hysteresis, and this is a number that accounts for the slight amount of backlash that's in the valve itself that can cause a valve to get off track by a few steps.
Yep.
Then you've got the overdrive at a nit setting. The valves are designed to be overdriven at the closed position so it can find its true closed position. This is normally about 10 or 20%, but the valves are designed to be able to do this. So then you have the fail-safe percentage, and this only comes into play if the stepper module has power, but it goes offline. Then after 10 minutes on the Danfoss setup, the valve will go to this Danfoss fail-safe position.
Right.
And you just don't want to leave it at 0, or you're going to have a bad day.
Yep.
I saw that one time in a store where everything was left at 0. There was a problem with communication wiring, and they didn't have a valve driver. So it was a scramble, to say the least.
It's good time. I just got an email yesterday from a guy on the East Coast asking what percentage should I set this at? I mean, I think he was concerned if he threw them all at 100, that just running flat out was going to be not great because of flood back. But he was going to go to a level of detail, maybe more than I'd expect, of actually monitoring the cases for a few weeks and seeing what the average opening degree was, and then plugging that number in. Which, if you've got the time to be able to do that, that's the perfect answer there. Yeah,
that's a good strategy. I mean, you can get away with more on low temp than medium temp, but you just need something to get you by in short term.
Right.
Yep. All right. And then the last 2 options you have, or settings you have, are the max phase current. That's going to be based on the manufacturer's recommendation for the valve. A lot of the Danfoss valves are 100 milliamps, for instance. And then you have a max holding current. Most of the Danfoss stuff, and even a lot of the Swarland stuff, that number is 0, because we're moving the valve to a position and we don't have to apply continuous current to keep it there.
That's correct. And we do have all this captured in a spreadsheet for all the different valve types, really, that you should come across. Anybody, yeah, if that becomes helpful for somebody, then whether it's the supermarket support site or just reaching out to Dave and I, then that's something we can get in your hands to help you out too.
Yeah. They could also email us at ControllerTalkNorthAmerica at Danfoss.com.
Shameless plug. I like it.
That's right. From what I hear, that would work. And you're right. It's on our website as well.
Yep.
So just a few more things about this valve that we should know. When you start installing these, or if you have to remove some because of a remodel, in the Danfoss controllers, you don't want to skip points on the stepper module. If you do, that can lead to some control issues for the points that fall after that stepped point on the board. If you do find a plug or a point that got skipped, just set up a spare circuit with a EEPR control and plug it in the unused point, and that's really all you need to do. Yeah. And these valves do something called an init on the Danfoss controller, and that helps verify their position, and it's done 3 different times. You can tell it to do an init in the service screen if you want to. You can perform a rescan, and that'll do an init. And the last time is that every time the case goes into defrost, it actually does an init there too.
Right.
Because it needs to know when the valve is closed, and then it can start the defrost.
Yep.
So, Chris, here's our question. How do we troubleshoot these things?
Yeah. So a few things we had mentioned already, and we want to kind of rule out the easy things first. Like you just said, did we skip any points in the program? If the valve's mounted at the rack, then we know that the distance isn't really going to be a problem. But if the valve's at the case and the board's in the rack enclosure, then distance is something maybe we need to just get a feel for. So those couple things, the programming is potentially somewhere we want to look to, right? If somebody made a change that they weren't completely sure about, or what effects it might have, if you change in controllers and the system managers, if you change your control type from EEPR to solenoid, and then say, that wasn't what I was supposed to do, and change it back to EEPR, well, you've lost everything. You've lost your board and point. You've lost all these settings that you just talked about for your step rates and max steps and those sorts of things. So you'll want to double check the addresses page in the system manager too, and make sure that the stepper valve's configured and it's configured properly with all those different parameters to match the type of valve you actually have.
Yep.
But yeah, beyond looking at the program, you kind of switch gears into the valve connection to the module itself. We know we've got the 4 wires going back to the stepper module, the 4 wires going back into that. We can't really take a meter and get any useful information out of trying to read a voltage on these. Different meters are picking that voltage, that quick pulsing signal that's going down to the motors and the stepper valve. And depending on when your meter's picking that voltage up, it could be halfway through the signal. It could be at the top, the peak of it. Nothing we can really take away from there and say that's useful. I'd say, if anything, if you're seeing constant voltage there all the time, maybe that would point towards the short or something along those lines.
Okay.
But otherwise, nothing with a meter that we're really going to look at. You can take the 4 wires of the valve off of the module, and these are bipolar stepper valves that we're talking about here with the KVS. So 2 wires are associated with each of the 2 motors in the valve. So red and green's usually one coil and black and white's the other. You can ohm out each of those 2 pairs of wires, and each pair should give you 52 ohms. Maybe a little bit of tolerance there where you're 2, 3, 4 ohms in either direction, but if we're way out of the ballpark from 52 ohms, then you know you might have a short or something like that in one of the motors of the valve.
Okay.
If you have something really strange going on, you can swap 2 stepper modules around. It's a pretty standard technique for us, is flipping, whether it's a comm module and a communication issue or something like this with stepper module control issues. You can always flip-flop 2 modules around and see if the problem follows the module or does it follow the valve, and that'll help point you in the right direction. Just want to make sure you're doing a rescan after you swap modules around, if that is something you're going to be doing. We do sell replacement actuators for the motors. Not too often we're seeing guys go in there and replace an actuator and leave the valve body in place. If you're doing it, maybe give us a ring and we can just talk about what all that entails. But by and large, if somebody has to replace the valve, then they're usually just sweating in an entire new valve in place of that. And so again, you get through all these other things we talked about in the program and the boards, and you kind of narrow that down or eliminate those other possibilities, and you say, okay, I think it's my valve now. These valves, the inside of that, the valve shaft that's kind of opening and closing to control your flow on the valve. Sometimes that shaft can get bent and rub against the body, and maybe we think we're opening it 50% of the way, and we're actually opening it 20% of the way because it's grinding against that. So yeah, There's going to be times debris gets in the system, and those sorts of things can cause those problems. And we say, okay, we've got to replace this valve and see if that's what it really is or not.
Okay. All right. That's a lot of valve stuff to digest, but I find it exciting.
Here you go.
Nonetheless. All right. So this takes us up to everyone's favorite part of the podcast, what we call Stump Chris, where I throw a question at Chris and we'll test his knowledge on little details. All right, so I need to ask you if, based on the statutes and laws of the state of Maryland, that I have not shared the question nor the answer with you ahead of time. Is that right?
I am quickly approaching Chris Davis batting average numbers here. So no answers on my side.
Yes, Orioles fans will be painfully aware of those numbers. All right, so this week's question has to do with the KVS valve.
Okay.
And something relevant.
I got cliff notes here. Let's see if we got my
Okay.
answers.
Yeah, let's see if you prepared. So we have the KVS 15 and the KVS 42.
Mm-hmm.
What is the travel distance on the piston for those, from fully open to fully closed, or vice versa?
We talking millimeters there? What unit
I
of
would
measure
like
we're looking
the units in inches, please.
for? Inches.
Yes.
Again, we're going to round off to a nice full number.
Well, maybe it does, maybe it doesn't.
KVS 15 full open, full close.
Yes.
Let's say 4 inches.
I'm sorry. That is painfully incorrect.
Yes.
That distance is 0.5 inches.
0.5. Oh,
Yes.
wow. Okay.
So half an inch.
I was thinking we were moving way further up that valve body.
Yes.
We're going to have to edit this part of the podcast.
Well, let's see if you can redeem yourself. Now that you have an idea, what is the travel distance on the KVS 42?
0.6. 0.7.
I'm afraid I'm going to
0.8.
have to accept that answer.
0.9.
It's actually 0.68 inches.
There we go.
All right.
1 out of 2.
Very good. I think you're getting better at these.
I don't know.
The jury's out.
Yeah.
All right. Hey, let's move on to listener mail, shall we?
Yep.
Okay. So as far as listener mail goes this week, we're starting to get a few more in. This one comes from Pepper in Patterson, New Jersey. Pepper is a real name, by the way.
Yeah.
His question is, how did you guys get your start in refrigeration, and why did you get into refrigeration? Do you want to go first?
You should go first because my story will probably involve you as part of the answer. So.
Oh, okay. Excellent idea. So I started in electronics. That's where my degree is in. Shout out Penn College in Williamsport, Pennsylvania. And I ended up here because my brother was working at EIL back in those days, and he took a job in Florida and said, hey, you ought to interview for this. And I said, I think you're crazy. I talked to Keith Bachman. At the end of the interview, he said, okay, so you have no experience in electrical, electronics, or refrigeration, right? I said, that's right.
You're hired.
Yeah, here I am 31 years later. So that's how I got into it. I find it really interesting, and it's a good position or industry to be in during a recession, in case you're wondering.
There you go.
Yeah.
I mean, my side, I did the 4-year mechanical engineering thing at UMBC, so got my bachelor's from there. As far as classes go, while I was in college there, thermo stood out to me as something that drew my interest. And so I finished up college, applied to some different companies that were in the area, and Danfoss, fortunately or unfortunately for them, I guess, decided to give me an interview and brought me on board. And then you had to put up with me directly for especially a few months there of absurd questions. I wish I had a podcast to listen to get instead of having to drill you about it.
That's right. Yeah, you were a quick study. I have to give you that. Then you passed me, so kudos to you. Yes, you were interviewed, and I wasn't even part of that process.
You were not.
I protested, but the guy was right.
We might not be doing a podcast together today if you had.
Well, you have a point there. All righty. If you'd like to drop us an email with a suggestion for a topic or a question or comment, you can email us at ControllerTalkNorthAmerica@danfoss.com. In upcoming episodes, we'll cover individual controllers and all sorts of things that might be of interest. So thanks for listening. Our studio and video engineers are Michael, don't call me Mike, Beckerman, and Jordan the Man Larsen. Our audio engineer is still the international man of mystery who we have never met, Raul Garcia. Until next time, for Chris Brown, I'm Dave Yoder. Stay cool.
Thanks, guys.